My name is Iqbal Khan. I'm a technology evangelist at Alachisoft. We're actually based here in San Ramon, plus we have an offshore office in Pakistan and a sales office in New York. I keep traveling between here and Pakistan, so that's why I was coming here instead of being here. Today I'm going to talk about how do you scale .NET apps with distributed caching. And the reason I'm talking about this is because we have a product called NCache, which is a distributed cache. I'm not here to try to sell NCache to you. I'm just our goal is to raise awareness about this issue, let people understand that they need caching if they're going to need to scale applications, and then hopefully if they reach that conclusion, when they look in the market, they will like NCache. So if you guys have any questions, please stop me. I prefer a more interactive discussion. I'm going to show you some concepts, some architectural diagrams, and some source code. So it's going to be, and that's why I was starting to get concerned when I could not start my Visual Studio. So, okay, I'm going to, just for completeness purposes, just go through a few definitions. I know that you know this already, but scalability is high application performance under peak loads. So what that means is you often confuse performance with scalability. If you have, let's say, an application with only 5 users and performance is really good, your application is not necessarily scalable until you go to 5,000 or 50,000 or 500,000 users, and you still have the same good performance. If you can claim that, then your application is scalable. If you don't have a good performance even with 5 users, then you have other issues. Maybe you've got an infinite loop or something, or making too many database calls, or so you need to improve your code. But you may have really good performance, and you may have designed your application really well, but it may still not be scalable. And linear scalability means that your deployment architecture is such that as you add more servers, you can get a linear growth in the number of transactions per second. So the scalability here is not about how much data you can store, although that is part of it. This is more about how many transactions, how many requests per second type of a load can you handle. So what you want is linear scalability, not a logarithmic curve, which would go something like this, right? Which means that there comes a point where after that, even if you add more servers, you're not going to gain any performance. You're going to probably lose performance. So which applications need scalability? These are your web applications, ASP.NET, or if you have Java, then you have Java or web apps. These are your web services, WCF or others. These could be any backends of Internet of Things, and these could be big data processing apps, or these could be any other server apps. But these are generally server apps. We're not talking about a desktop application. We're talking about backend applications that need scalability. So if you have one of these applications, you should be thinking about the issues that we're going to talk today. So let's define the problem for which I'm giving all this talk. What is the scalability problem? Well, the application tier is not the problem. You can grow the application tier in a linear fashion. You can keep adding more servers. You may have a load balance web farm, where there's a load balancer, and you can grow by adding more servers. The data storage is really the problem, and it's that data storage problem which triggered the NoSQL movement, by the way. So the data storage was not able to handle the load, the transaction load, so that's why the NoSQL movement started. And NoSQLs are great databases. I'm not at all trying to shoot them down by any means. They just don't solve the problem for a lot of reasons, because you're not able to use them. Unless you use a NoSQL database, you're not going to solve the problem, right? So if your business is not able to move away from your relational database or your legacy data to a NoSQL database, because NoSQL requires you to move away from your existing database to a new database. It's a better, more distributed database. If you're not able to do that, then you can't benefit from a NoSQL. So what do you do? you're stuck in this situation where you have to use your relational database, and this could be SQL, Oracle, DB2, MySQL, any relational database. It's not any one database vendor that has problems and others don't. So you have to do something about it. So that's where the answer is to use a distributed cache. Um, NCache is one of those examples. By the way, NCache is an open source distributed cache. So anything I say is, I'm talking about an open source product. So the solution is to use a distributed cache with your existing databases. And why is that a solution? Let's look at this from an architectural, like a deployment perspective. If your databases are the bottleneck, then if you put a caching layer in between the application and the database, what you're doing is you're reducing the traffic to the database. So about 80% of the time you will be getting your data from the cache. And it's a distributed cache, unlike being a standalone cache, which will reside within your application server. This is a multiple servers. A minimum of 2 servers is what that's what makes it distributed, is to have a minimum of 2 servers. And any distributed cache, any good distributed cache, like NCache, would create a cache cluster. So there's always a cluster, and this is not an operating system cluster. It's the cache builds its own cluster. NCache, for example, builds a TCP-based cluster, so multiple servers can pool their resources together, and this cluster is what makes it scalable. This is what makes it highly available. This is what where the real magic is. So having a cluster with 2 or more servers means that this no longer becomes a bottleneck. I mean, this never becomes a bottleneck. The database, because you cannot grow it in this fashion, the database becomes a bottleneck. But a cache does not become a bottleneck because you can add more servers. And these are usually 64-bit boxes because you want more and more memory. A typical deployment that we see in our use, and by the way, NCache has been in the market for about 10 years, so we've got a lot of experience understanding what the space is. We're the oldest .NET distributed cache. So what we typically see is each box having about 16 gig of memory is a standard. Some people would have less than that, and some would have 32 gig or 64 gig. Even we've got customers using 128 gig in each box. But a better strategy is to have more boxes with less memory, because as you have more memory, the hardware specification of the box has to also become stronger, because more memory means more garbage collection, more processing, which means a stronger CPU, and so you're becoming more and more like a database, which defeats the whole purpose of having a cache, which is supposed to be on more commodity hardware. So having 16 to 32 gig is pretty much the sweet spot of memory that you want, because there you can use a standard web server type of a configuration, dual CPU, quad core type of a box. So there are 2 things. One, you want to have a lot of memory. Second, you want to have the network cards. You usually, have 2 network cards in each box. One that caters the client, request. One that does the cluster communication. So then you're, maximizing your throughput. So this is how a distributed cache removes the scalability bottleneck. That's why it is what I'm calling the solution to this problem. This picture is slightly misleading. It implies that you're always going through the cache to your database. That's how it's laid out. I just didn't have enough space to show it both ways. So, but in reality, there are 2 methodologies. One is what we call the read-through methodology, which is you go through the cache, you read the cache, and if the cache doesn't have the data, it'll go get it from the database. The second is where the cache is actually kept on the side here, and you're going to the database just like you're doing today, but whatever you get from the database, you cache it. And that the next time when you're going to want to go to the database, you'll first look in the cache. If the cache has the data, get it from the cache. So both ways you achieve the same results. There are some pros and cons of either approach, and I'll talk about that. But the goal is to have about 80% of the time not go to the database. 20% of the times you have to go because you have to do the updates still have to be made to the database. The database is still the master data, repository. The cache is only temporary storage. So that's why all the updates have to be made to the database, and some reads also have to be made to the database, so that the cache has the data. So this is how a typical cache deployment looks like. Any questions on this so far?
What's the throughput on the network cards typically?
Minimum 1 gigabit, but these days 10 gigabit is pretty much standard. And again, as I said, because you add more and more servers, unless your objects are really big, unless every object is many megabytes in size, your network card is not the bottleneck usually. But if your objects are bigger, then the network card can quickly become the bottleneck. There's also features like compression. Like NCache has a feature called compression, where if your data is not already compressed, if it's not JPEG or PDF or anything which is already compressed, if it's more textual data but it's large data, and if it's above a certain threshold, it probably makes sense to compress it before sending it to the cache, because the trip becomes faster, and the extra cost of compression at the client side is less than whatever you gain by sending a much smaller. If you compress textual type of data, it comes down to be about 1/5 or 1/4 of the original size. So there's a decent amount of gain. Good question. Any other question? Okay. So what should be some of the scalability numbers that you should expect if you're using a distributed cache? I'm going to just give NCache numbers. You can look at other numbers. 50,000 reads per second in a 2-node cluster. With the 3, it'll go 72, 96, 120, and 144. Pretty linear scale, and the writes are also linear, but these writes have replication built in. I didn't give the numbers where one of the topologies is where there's no replication. When there's no replication, the reads and the writes are pretty much the same performance. When you're doing replication, because cache is all in memory, memory is volatile, so if any one server goes down, you don't want to lose the data, and I'll talk about that also. Then that extra cost, which slows down the updates, but it's still pretty fast, and it's still a linear curve. And with this type of a number, you can see that if you have a high traffic application, let's say if you're an airline or some online business, you're a bank or something, and you've got lots of people logged in, that with this type of performance, you can rest assured that you'll never have a bottleneck. And that's the key in this: scalability and not performance. So there's performance gain in using a cache because it's all in memory, and there's also some features called the client cache, which a subset of this cache sits on the client box, which is even a further performance boost. But the reason for using a cache is not performance. I mean, I haven't seen people complain about database performance with 5 users, unless, as I said, you've just done some really bad programming. Databases are pretty fast, but they cannot scale. They cannot maintain that performance as you add more and more load. That's the real key. So I think that is where people also get confused about performance and scalability. You want to use a distributed cache when you have at least 2 servers in the application tier, and of course 2 or more, because that means that as you add more and more servers here, the database is going to become a bottleneck. What we've seen also is, in an average case, in an e-commerce type of an application, about 1,000 concurrent users is a very good point to start using a cache. Some people use it even prior to that. That depends on the nature of the application. But definitely, if you have more than 1,000 concurrent users, that you want to use the cache. And you might say, I'm not having any problems today, so why put in the cache? Well, it's one of the best practices now. Everybody has pretty much validated this concept. We used to have a lot of difficulty convincing people that they need caching. And then more and more larger companies started to adopt. Microsoft came out with App Fabric, which turned out not to be a very, successful product, and they're discontinuing it now, and they've now adopted Redis. But it validated the concept. It convinced everybody that caching is a best practice. If I'm going to architect an application for scalability, I must incorporate caching. It doesn't matter which cache you use, but I must incorporate distributed cache in my application.
Actually, can you go back to those write performance numbers? So those write numbers are writes into the cache, right? It's not writes all the way back through to the data.
Yes, they're writes into the cache with replication.
Right.
So you update one node, and it updates at least one other node itself. So that whole thing combined. So these are the numbers, and this is with the 1K object size.
So in order for that means your data source in the back end has to be able to support that level of variance as well.
You can also queue up. In case of NCache, there's a feature called write behind, where you can queue up the database updates, and so that way the database is not going to become a bottleneck, and you update the cache, and then you can go out and do your stuff. But the fact that you're taking all the pressure off of the database for the reads also means that the updates are now much faster, because there's no competition with the reads.
You said it was right behind?
Yes, right. And I'll talk about that.
Okay, cool.
So once you're convinced that distributed caching is something that you need, then the next question is, well, how do you actually use it? What are the different ways to benefit from it? So there are three common uses that we've seen, and that we also support in NCache, but these are pretty much common in the industry. The number one is application data caching. Number two is ASP.NET specific caching. And number three is runtime data sharing through events. The application data caching is what I've been talking about up until now, which is caching your database data. So the data exists in two places. It exists in the cache, and it exists in the database. So everything that we talk about application data caching in this presentation today needs to keep this in mind. A good distributed cache needs to handle for this. So what are the issues what is one of the main issues that might come up if the data exists in two places? Inconsistency. So if a cache does not handle that, then you're forced to cache only read-only data. And read-only is a very small subset of the data. It doesn't give you real bang on the buck. So you want to cache both read-only data and what we call transactional data. These are customers, your activities, whatever is being generated at runtime or updated at runtime. If you cache that, and the cache is able to keep that data consistent with the database, then you've got a really big boost. So the application data caching is what it is. So the second is, if you've got an ASP.NET application, there are at least three things that should go into the cache: the sessions, the view state, and the page output. The view state only if you are not using the MVC framework, which most people are still not. All the new applications tend to use it, but a lot of the existing ASP.NET applications still use the view state. So put these three also in the cache, and I'll talk about that also. And then in this case, the data exists only in the cache, so there is no database. Then in this case, the sensitivity is that the cache cannot lose any data. In case of application data, if the cache loses some data, you're not, the sky is not going to fall. It's gonna, you can just go to the database and get the data again. Although there's a performance hit, because if you have to go to the database to reload that 16 gig of data or 64 whatever gig that you had cached, that is going to have a performance drop in your application. That's why you want replication even in application data caching. But in ASP.NET specific or runtime data, you must have it. It's just not. It's really you're playing with fire if you don't. So for example, Memcache is a very popular cache. They don't do any replication. So without replication, if you use them for any transient data, you're running the risk of losing data if any one server goes down. So if any other cache does replication, then they're safe in terms of using this. And the runtime data sharing through events is something which a lot of people don't know that you can do pub/sub type of event notifications through a cache. But think of a cache as a very powerful event, uh, like a message bus, like a eventing platform. So all these clients, all the applications are connected to this, so they can talk to each other through this, and they can do coordination in a pub/sub fashion. There's a continuous query feature, the event notification. I'll talk about that too. So traditionally, people use message queues for this. They're great products, especially when it comes to ensuring that the message is always delivered and also in a distributed, like in a multi-location setup. But if everything is within one data center and it's a high transaction application, then message queues do not scale very well. And the reason they don't scale is they don't build clusters like these. If you use a distributed cache as the event engine, then it's very scalable because you can keep adding more boxes just like you would do for an application data caching. So those are the three main uses of a distributed cache that you should consider using for your applications, depending on what the nature of the application is. Any questions before I go to the next part of the presentation? Okay.
Quick question.
Yeah.
I'm sure you're going to cover this, but so when your server's talking to the data, you've originally been talking to an SQL server. Now you're going to talk to the cache. Does the cache still get the queries in the same way, or do you use a new query?
So whatever data you're going to get from the database, that code stays the same. Whether if you keep the cache on the side, when we talked about the picture here, that the cache is on the side here, so nothing changes in your code as far as going to the database. In a read through, when you're going through the cache, then your code is the one that sits here that cache calls, and that your code then can issue the same type of database queries that you would even without the read through. There are some other features in the cache which allow you to search the cache itself as if, so for example, if you had populated the cache with a lot of reference data, so you've got the entire tables put into the cache. So now the way that you use the cache, and now let me just go to that page. I'm just going to skip it and I'll come back.
Well, if you're going to cover it later,
Yeah, okay.
let's cover it in sequence.
Okay. So let's now get into this part and see what is it that you need to do the application data caching. And I'm going to use NCache as the example in this, but as I said, my focus is more on the caching itself. So here's a typical view, or a typical example of how you would use the cache. You've got some sort of a load function. You're going to load a customer from the database, but before you go to the database, you'll check the cache. And to check the cache, you need to build a key. In case of NCache, the key is a string key. It can, you should usually, it's a, just a recommendation that the key should contain some information about the type so that you can uniquely define keys. So this is the class name, the attribute name, and the actual value. So this makes the key, and you use the key. If the cache has this data, no need to go to the database, just return. Otherwise, go and get it from the database and then put it in the cache. So just a very standard paradigm of how you would use the cache in majority of the cases. So as you can see, the cache part is very, very straightforward. It's a key and there's a value that you typecast to your object, and you can do a cache.insert. Insert means add this into the cache if it doesn't exist. If it does, then update it. So it's like an add or update. It's called insert. And then so this is how a typical code would look like. Let me actually at this stage show you. So I'm going to if I go into come on. Okay, so in a typical app cache usage, the cache usually has so there's the cache servers, which could be on the same box as the application or a separate box. Usually in a separate box, if you've got, as I said, 3 or more servers, then it's better to have a separate caching tier. And there's a client portion of the cache, which is just the client library. So here's what you would do is you would reference the libraries. Like in case of NCache, you'll just do ncache.web and ncache.runtime. Then you would use the namespaces. In case of NCache, again, you'll use the same namespaces. And then at the beginning of your application, here, actually, let me quickly show you this first before I go into that. Let me show you. So here's how the API looks like. So a cache, just like a database, you connect to the cache at the beginning of your application. You keep the connection handle, and you use that throughout your application. To do your operations, you can do get, contains, add, insert, remove, and a bunch of other operations. And at the end of the application, you disconnect with the cache. Now, other caches may have a different method name, but the idea is the same. You get a handle and you keep the handle. Unlike HTTP, where every time you that better?
One question. Do you need to keep connection for all life cycle of application, or just when you access data and then immediately close it?
It's actually preferred that you should keep the connection open, so that you don't have to. Because every time you open the connection, it does some initialization of the stuff. So it's a good idea. At least in case of NCache, it's a good idea to keep the connection open. Okay. So here's what you. So all caches are named in case of NCache. It's like a database, and on the same set of servers, you can have multiple caches created. So now that you've got a cache handle, you build your object, and then you do cache.add. So cache.add has the key, the value, and for example, it is specifying absolute expiration. I haven't gone, so it's going to say expire this object 10 minutes from now, regardless of what happens. And then you can do a cache.get, you can get the same thing back, and then do other stuff. I'll come back to that. So here's what a typical code looks like, and here's what the API looks like. Okay, now let's go into some of the caching features that you need to know and use. So if you're going to use the cache for application data caching, where the data exists in two places, right? So this is what you need to keep that in mind. So the most important thing is to keep the cache fresh, right? So how do you do that? Number one is expirations. So for application data caching, you use what we call the absolute expirations. This is what we just used here, right here. So that's an absolute expiration. And this, you just specify, so you make a guess, and different types of data will have different expiration. So your reference data is not going to change for hours or days. Your transactional data, you probably don't want to cache it for more than 5 minutes. So for everyone, you will specify, and this is a guess that you're making. So for this much time, I don't think this data is going to change in the database. It's safe to keep it in the cache. It's not going to go stale. But it's still a guess. The sliding expiration is another type of expiration which is usually used for transient data. So for example, when you've got your sessions, so you want to keep the session as long as the user is logged in and reading and being active. Once the user logs out, no requests are coming for the session. So there's inactivity. So whenever you have inactivity, you want to say, okay, if this much of inactivity happens for this long, expire this thing. But that means, see, the sliding expiration is more of a cleanup. Absolute expiration is more of keeping the data fresh or synced up. Sliding expiration is for cleanup. So this is an important thing to keep in mind. That's why you want to either use this or this, but not both. Because in in an application data, it doesn't matter whether the user is accessing the data or not. You want to expire this 10 minutes because you think it's only safe for 10 minutes because somebody might go ahead and update that data. So that data might be fetched over and over and over again in that 10 minutes. You're still going to expire it. But in sliding expressions, you're not going to expire this unless nobody's using it anymore. So as I said, it's more of a cleanup. So that's the first part, and I showed you the absolute expression, and here's the sliding expression. In case, and this is NCache, of course. So I fetched the same object again, and I made some changes to the object. Now I'm going to do the update, but in the update, I'm going to also change the expiration strategy for no reason except just to show you the code. So I'm going to say don't do any absolute expression, but do a 20-minute sliding expression. So sliding expression takes an interval value, a time span value. So with this, you're telling NCache, expire this after 20 minutes of activity. And this is exactly how ASP.NET sessions are expired, and also view state and others. Okay, but expirations are only a guess, and your guess could be wrong at times, especially if you have an application where, if you have a database which is being updated by multiple applications. Then another feature that you need is to be able to synchronize the cache with the database. And that means the cache should synchronize itself with the database, not you. I mean, you are the application. The cache is this other entity. So the cache should be able to synchronize itself with the database. How does the cache synchronize? SQL Server has this feature called SQL cache dependency. Has anybody used that feature? Okay. SQL cache dependency essentially allows you to specify a SQL statement. Let me show you the example here. Okay, right here. Okay, so which one is this? Okay. Sorry, not this one. Another one. Where did it go? Just give me one sec. I had put that in this because I had accidentally deleted. There it is, samples. I have a problem opening that double click, so that's why I'm taking a painfully longer route. Okay. So in a SQL dependency, what do you do? When you add, you definitely don't want to do this. This will empty the cache. I don't know what I was doing at the time. Okay, so what you do is when you're adding something to the cache, you specify a dependency. So here's the key, here's the value, and here's the dependency. So the dependency is a cache dependency object in an NCache, which internally uses then actually, or maybe it is not NCache, it is a no, it is an NCache, but internally it uses the SQL Server SQL cache dependency, and so you've specified a SQL statement. So here's a SQL statement. So you're saying, this is my data set. It's, so you're saying just one row from a product table, right? So you're using the primary key of the product table. So you're saying this cached item is mapped to this one row in the table. If this row is ever updated, deleted, or deleted, please notify me. So because the database has, SQL Server has this SQL cache dependency feature, Oracle has an Oracle dependency feature in the same fashion, which both of these use database notifications. So NCache now becomes a client. So here NCache here, it becomes the client of your database. So NCache, so the application tells the cache, add this item with the SQL dependency. The cache issues a SQL cache dependency against SQL Server, and then now becomes a client. So when now SQL Server monitors that data set, this data set, and if this data changes, SQL Server sends an event notification to its client, which happens to be NCache. And NCache has a mapping now of its cached item, which is this key, and this SQL dependency. So it's okay, the database has told me that this corresponding data in the database has changed. So I better remove this cached item. So what does the cache do? NCache goes and removes that cache item from the cache. Why does it remove? Because if it's not in the cache, it can't be stale. The next time the application looks for it, guess what the application is going to do? If the item is not there, if it's null, it's going to go to the database. So by going to the database, it's going to force itself to go to the most recent copy. There's another variation of this where instead of removing it, the NCache can refresh it, which is with the help of this read-through mechanism, which is your code. So NCache knows, that well, you've told NCache that, when the database version of this data changes, please reload because I'm going to need it anyway. So instead of me going to the database and reloading it, why don't I just ask you to reload it from the database? So that's where SQL cache dependency feature mixed with read-through automatically reloads. That's the auto refresh. So the same thing happens with Oracle dependency. So this feature, synchronize the cache with database, takes all of the guesswork out of your work. So you can now rest assured that if the data changes, the cache is gonna be immediately either it'll get invalidated or it'll get reloaded. Any questions?
What's the overhead for doing something like that?
Very good question. I was just going to say that, but you've just asked that. So SQL dependency is a great feature, but if you have 10 million cached items, which is not an unheard of thing, or let's say you have 1 million cache items, just make it more likely. You're not, and if you create 1 million SQL dependencies, for every SQL dependency, SQL Server creates a data structure within the database server so that it can monitor. So from that point onward, all the database transactions, which are updates or deletes, have to be compared against this data set. So that's a lot of extra work for SQL Server to do. So guess what's going to happen? Can anybody guess what's going to happen to SQL Server? Yeah, it's going to crash. It's just going to die with 1 million. I can guarantee you that. And we've actually tested it too. So, but we're talking scalability. So we're talking large numbers. So, but not all data is going to be 1 million because there are different types of data. Some data, you're just good in just guessing with expiration. That's the most efficient thing, right? You're just on the cache and you're just going to remove thing. And almost every cache that you see in every distributed cache available in the market, free or commercial, supports expirations. But SQL dependency, I think only ASP.NET Cache Object and NCache are the ones supporting it. And you would need it in many cases. Some data you need to synchronize. Some data you can expire. And some data is not even, it's too much to even do SQL cache dependency. So if that happens, then the next approach is called DB dependency, which is a feature that NCache has, where instead of getting events from the database, NCache polls the database. So there's a special table that gets created. It has some special columns that will contain the flag or some value in it. And NCache will do a fetch and say, give me all the items that have been updated in the database. And it'll get all of them. Maybe it'll get 1,000 of them or 10,000 of them. And then for all of those, in one fetch, it can synchronize them with the cache. And synchronization means it'll remove or it'll reload. But in one fetch, it can do for 1,000. So that is more scalable than SQL dependency. It is not as real time because these polling, you have to specify polling interval, which probably at least 15 seconds or 30 seconds, because you don't want to go to the database every second, right? So for 15 seconds, the data might be stale. So, but that's the trade-off between SQL dependency being real time or almost, it's much more quicker than 15 seconds, and DB dependency being more efficient. But even with 1 million items, DB dependency would also, not be a very. I mean, how large of an index would it be if you got 1 million items and there are only true and false in them? I think it's got more than 2 values, but let's just say 3 values or 4 values. So if you've got a lot of data that needs to be synchronized, then a better strategy would be to do the CLR procedures. So that's the third one in this right here. CLR procedures are something that SQL Server supports. You can write them in .NET, in C# or VB.NET, and you can call them from database triggers. So let's say you have a customer table, or let's say you have the same, you have the product table, and you have an update trigger on this table that whenever this product row, any row is updated, it calls the CLR procedure. And the CLR procedure does what? It takes the primary key. It now knows that it needs to build a key like this, right? Because this is your code. And it goes and says to the cache.insert, and sends the new product object to the cache. So it actually builds the product object, sends it to the cache. So very efficient. The only drawback with this is that within a database transaction, you don't want to make synchronous calls. Maybe when Jeremy comes here and talks about async methods, you can plug that into this concept. And basically what you need to do is make async calls to the cache, because you're sitting here within the database and you're making a call to the cache, and this call may be updated to multiple servers, and it could actually slow down your database transaction. It may start to time out. And when a transaction times out, it will roll back all the updates, if it's part of a multi-update thing. So for NCache, at least, there's an async method built in, so that you can make an async call where you will immediately send the call and come back. So if you're going to make cache calls in case of NCache, then use the async methods. But a CLR procedure is good when you have a lot of data that is not suitable for SQL dependency and DB dependency. Any questions? I'm going to take a 1-minute break and just get something to drink. I've been talking for a while, so.
And we can make it also a 5-minute break, so.
Okay.
If you want.
Whichever. Yeah, I think that's fine. I'm just going to pause this. Okay, so. Okay, so we had finished the synchronization of the cache with the database. Any questions on that before I move on to other features? So that the same rule applies with non-relational data sources, where you want the cache to update itself if your data changes. It doesn't have to be relational databases. You could have other storage. You could have a mainframe data, and the only way to communicate with the mainframe could be through a file which gets either created or updated or something. Or you could have your data in the cloud, and the only way to check is to make a web method call. So that would be your custom code, which you would register with NCache. NCache would call it at specific interval, you would go and check your data source. If the data changed, then you would tell NCache that the dependency was fired, or it was triggered, and then NCache will do what we just talked about. It would either remove the data from the cache or reload, depending on how you had specified this. So basically, explorations and synchronizing the cache with database or data sources. So those are the three different features. Fourth is, if you have relational data, it has one-to-one, one-to-many type of relationships. Often, if you have these objects stored separately in the cache, let's say you have a one-side object customer with multiple orders, so all of them are stored in the cache. Although you normally don't delete a customer, but let's say that you deleted the one side from the cache, the many side should also be removed from the cache. And the reason is because the NCache does not know whether you're also removing it from the database, and there was a relationship, so that relationship no longer is valid within the cache. So you want to be able to remove. What you want is for the cache to automatically remove all the related objects if the object on which these objects are depending is removed from the cache. Did you understand my? So with this, again, this is one more way where cache is keeping track of these relationships. So your application does not have to keep track of them, because if you had to keep track of every object that depended on every other object, then you would build your own data structures in memory to keep track of these. So why do all that work? Let the cache do it. So that's another feature. So all these four features allow you to ensure that a cache is fresh. I hope that with this, you will be convinced that you can put almost any data in the cache. If your cache supports these features, you can put any data in the cache, and you can truly start to benefit from the cache and not just use it for a read-only cache. Okay, now that you're starting to put a lot of data in the cache, you need the ability to find it, and keys are not the only or not the most friendly way to find data. Imagine if the only way to find data from the database was the primary key. How painful would your programming become? So so as you add more data, especially let's say if you're adding a reference data, you've loaded all the products in the cache. Now and you need to now search for certain types of products. So one way is to if your cache did not do any of these, which is, let's say in the case of Redis, which it doesn't, you would need to fetch everything from the cache based on the key that you either remembered all the keys, or you had some sort of a key pattern that you could build on, or you just enumerated the entire cache. And then from that whole enumeration, you would find the actual objects that you wanted, because the cache is not creating any indexes. So, but in case of NCache does create indices, so it will let you do SQL type of searches. So you could say something like select customer where customer.city equals San Francisco. It'll give you all the customer objects, and let me show you that also. It'll give you all the customer objects that match that criteria. So, and that's what makes NCache much more friendly, and any distributed cache that provides that feature, it makes it much more friendly. So again, we do the same thing here. You've got a lot of data added, and now you will specify your criteria. So you'll say whatever the object type is. In this case, it's just a string, but in another case, it could be a customer object. It could be a complete namespace, or whatever way you want to specify that. And then you specify some sort of a criteria. In this case, it's specifying the primary key, but this could be, as I said, customer.city equals New York. It could also be any other attribute. So based on that, now you will get a collection back. So you will this code is old. Now we have a results set paradigm, just like SQL Server, where you can get the result set and then you can enumerate over it. So being able to search the cache in a SQL-like manner, or do the link, same way that you did this, there's also link that you could do. See, let me just create a second. So in case of link, you would again, so NCache, for example, has a link provider implemented. So you would do an I queryable, and you would pass the cache handle to this, and now with this, you can search it just like a link query, and you're actually searching the cache. So if you're more comfortable doing link searches, you can search the cache. If you're more comfortable doing SQL type of searches, you can do it that way. But in both ways, the difference has been that now the cache is becoming like a database for you, because you're putting in a lot of data, especially reference data. Now, one thing that you should keep in mind is that if you haven't loaded all the data set in the cache, then do not do SQL searches. For example, if you did not load all the customers in the cache, and you did give me all the customers, the customer.city equals New York, you only get a subset back, which, the cache only has a subset. So, that is incorrect. So the only time you want to do a SQL type of search is when you know that the entire data set that you're searching is already in the cache. So this is mainly for reference type of data. Any questions on this?
Is there a way to set it if you've got a team to make sure that somebody doesn't go off and think that all the data is there when it's not, and start using that approach?
No, actually, it's pretty much under your control. So it is more of a recommendation on our part to say use the SQL searching only on that data which you know the entire data set is in the cache.
But I don't have the ability to set a flag that says this isn't available, so that if somebody does try to do that.
No, because again, I mean, let's say that you had loaded all the customers, and at that point in time, all the customers were, that was your entire data set. But then a couple of hours later, somebody adds a new customer, but they didn't add it to the cache. They added it straight to the database. So unless you use something like a CLR procedure to also populate the cache automatically, which you can, which is one of the synchronization of the cache with the database is not only updating existing data with the database, but it's also adding new data, especially if you're going to use a CLR procedure. So for some data which you want to make available for searching, you need to make sure that the cache has the entire data set. And the way to make sure is to first populate it completely, and then from that point onward, use something like either the CLR procedure or whichever application is adding it to the database should also add it to the cache. And once you have ensured that, then you are safe to search the cache. Or else, if you don't ensure that and you search the cache, you will get incorrect data. It's only a subset. But a lot of data, as I said, is reference data that you want to be able to search. Why go to the database when you can get it from the cache? Similarly, there's also bulk get features, because cache is a separate process. Even on a separate box. If you have to load 1,000 different items, don't make 1,000 trips to the cache. And in memory, in proc cache, which is within your application process, you can probably make 1,000 calls, and it doesn't matter. But when you're going across processes, and especially across the network, even if it's the same subnet, 1,000 calls are going to be slower than one database call. So there's no need to cache if you're going to make 1,000 calls. So if the bulk up, so a good distributed cache should provide you bulk get. That bulk get will actually ensure that in one call you specify all the keys, and it'll go and get all that data for you. Any questions? Okay. Data grouping is another very important feature. Again, so that you can add more and more data to the cache. You want to be able to associate multiple items together logically, so that instead of searching it on an attribute, let's say you may not have an attribute. Maybe you're just adding stuff and you're calling it my important whatever set of objects. So there is a concept of a group and tag and name tags. These are essentially metadata that you can associate the cached items with. So when you're adding something to the cache, you can say it belongs to group A. So all the items that belong to group A, you can fetch them all in one call. Or you can remove them all in one call, and so on and so forth. So the same thing goes with tags. A tag is nothing but a string. It's just like a group, except tag is a little bit more loose. More, that you can assign the same tag to multiple items, and you can have one item assign multiple tags. And you can say, give me all the items that have these tags. Name tags is again like tags, but there's a key value concept. So if you have, for example, textual data, if you're adding objects, there's attribute and the attribute value, right? So the city is the name of the attribute, the value is San Francisco. What if it's not an object? What if it's all plain text? But you know that it has, and you've parsed it, or maybe it was XML or something, that you've got these attributes. So you can say key and value as metadata. So you can assign multiple of those to that item. And later on, search on those and say, give me all the things where the name tag key is city and the value is San Francisco. And the data grouping, these features can be accessed through special API and NCache, but more importantly, you can include them in SQL searching. So when you search the SQL, you can say where customer.city equals New York and customer.group equals group A. So again, different ways to be able to search data. This is, if you don't have these features in a cache, then you're limited. Your use of a distributed cache becomes limited. And if you only had a little amount of data, it's probably okay not to have these features. But if you're going to make some serious use of the cache, then you want to have these features, just like you want to have searching capability in the database. Any questions?
One question. So you mentioned that you mostly put reference data into cache. And
for searching.
Yeah, that's right. And if you have cross-reference, for example, you have two objects that reference each other, and you put them both into cache. Right. How it's resolved? And which serializer are you using?
Actually, so are you saying that you have multiple, let's say you have a collection of objects, and for every object you've got separate collections? Is that what you're saying?
No, for example, you have objects that reference each other.
Right.
And you put them all into cache.
Okay, so one way to do that is to, okay, so.
Could you repeat the question?
Okay. So the question that he asked was that how do you handle references between multiple objects in the cache? So if you got a customer, how do you ensure that you get all the orders of that customer? Is that the question that you had? So if you had a one-to-many relationship, how do you ensure that? I think you do that through the way you construct the keys. And again, it depends on how you've stored the collection. Let me give you. I'm going to quickly deviate from this and go into another presentation that I usually give, which is entity framework, in which I have an example of that. That's why I'm going to give that. Where did that go? If I go into EF caching, so I don't know, can you see this? Okay. So for example, here in an entity framework, I've got a situation where I need to cache one-to-many relationships. So I've got a customer, so I'm going to cache the customer. So here's my customer key. So I'm going to cache that right here. So I just cache the customer object. Now I need to also cache all of its orders. So there are two ways that I can do it. One, I can treat the entire collection of orders as one object and cache it as one item. So that's what this example does. Okay. And this is probably the more common way to do it. And I would say do this as if you know that these objects in the collection are not going to be changed by anybody in the time that you're caching it. Because it's really easy, right? So because then you can, the key for this is this. It says customers, orders, customer ID. So you're actually fetching it based on the customer ID, not based on those order IDs. See what I mean? So you always want to access it from the reference of the customer object. So it's a one-to-many relationship. In other cases, you might actually want to keep the customer separate and every order to be separate. So then you cache the entire collection as a separate object. When you do that, you assign tags. So the tag could be the customer ID. This tag could be customer : customer ID : the actual value. Then at any point in time, you could say, give me all of the objects that match this tag. And then you will get the entire collection of orders back for this customer. And now the orders are cached separately, but they are also sort of tagged. So this is one example of how you can use a tag. So both are valid cases. In one case, you want to access individual orders separately because you might want to update them. In the other case, you know that you're never going to access them separately or independently. It's going to always be part of this one customer. Did that answer your question? Any questions on this?
I'll create a cache like this. I create a cache of all the product orders for a given customer. And Jeffrey comes along and he wants the orders for the same customer. It just goes out and reuses that same cache unless it expires, right?
Exactly. Because he will use the same key format that you have. It will say something like, what happened to my mouse? So he will say something like the key is customers : orders : customer ID. So he's saying, give me all of the orders for this customer. So then he'll get the same collection back that you had put in the cache, because it's a common cache across multiple application instances.
And what kind of serializer do you use for reference objects?
NCache uses binary serialization, which is actually pretty fast. Now, there are some issues with entity framework and serialization that I'm not going to go into, because then it will deviate from the topic. Let me go back to this. So, I mean, I hope I just showed you an example of how you could use tags to group things together and be able to quickly fetch them later on. And again, because you're dealing with key value stores, these features become really important. Okay. Read through, write through. So we talked about this. This is your code that you implement to go to your data source, and it gets registered with the cache server. So let me show you what the code looks like. How much more time do we have?
30 minutes.
Okay. I'll see if I can get it done even sooner than that, but let me just, so, backing source. Okay, so for example, what does a read through look like? So in case of NCache, there's an interface called iReadThrough provider that you implement, and it has three methods. There's an init method that gets called when the cache starts, and it calls you, your code so that you can do your own initialization, like connect to the database or other stuff, and it gives you an iDictionary in terms of the parameters. The second is dispose, which the cache, when the cache is stopping, it calls this, so in case you need to disconnect with your data source. And then once that is done, then while the cache is running, every time you do cache.get, and you're telling the cache, if you don't have the data, please call the read through. Then the cache will call you with this key, which is the key that your application gave to the cache, and it wants this as the output, the cache item. The cache item is actually a structure that contains your object plus more metadata. So here's your object. So this is your customer object. And then it might contain like, do you want to resync on expiration? It says true, of course, because you have a read through now. So why not resync on expiration? And you can specify other attributes of this. So this will get called every time you do a cache.get, and you tell the cache, call the read through if you don't have the data. Now this is your code that you compile in an assembly, and you register that assembly with NCache. I'm not going to show you how to do that. NCache has this tool called NCache Manager, which lets you do this from a single place in a graphical manner. So it's really easy to do, very easy to do. Same way is the write through. Exact same way. It's got another interface. It also has init. It has a dispose, and then instead of read, it has a write to data source. In case of write through, it has two overloads. So there's a write to data source like this, and there's a write to data source with an array of operations. And the reason we did this is because you could do bulk updates, and also for write behind, so for example, if you want to do the write behind, you could either initiate this as a write behind, or you could say if the database connection, if you're not able to connect to the database, queue it up. So at least the cache gets updated, and then the cache will, in the background, operate on the queue. And when it's a queue, it's got multiple items. Then it can do bulk updates. It can do optimization. So if the same item is being updated twice, it'll skip the first one and update the second one. Stuff like that. But read through, write through is a very powerful concept, and this allows you to put as much of the database code in the cache as you can. And again, you don't use this for every type of data. For example, if you had to issue a multi-table join and get a collection of objects back and cache some of them and not the other ones, then that's not a read-through method. Read-through method is good when your database call results in whatever you get back, you want to cache it as one item. So if you're not interested in caching it as one item, then call the database directly, and then cache whichever ones you want. Any questions on the read-through, write-through? Again, a very powerful concept. These are the features that will, as your cache has more and more of these features, then your life becomes easier. And we've talked about the auto reload on expiration and database synchronization already. Runtime data sharing with events. So there's a key-based event. So there's an on. Let me quickly show you this. I think events is this. Okay, so for example, there are different types of events. Here's a key-based event, here's a cache level event. I think this is a cache level event. So you're saying, here's my callback. Call it whenever any of these things happen. So this is item added, item removed, item updated. And so basically you're saying whenever any item is added, updated, or removed in the cache, call me. So this callback gets called. So you will then you get the key and the object, and then you can see whatever you want to do with it. In some cases, you want to be notified on specific items. So for example, here's a key-based notification where you're saying, whenever this item is added to the cache or updated or removed, notify me. But you're only looking for a specific key. Another way to make sure that you are notified when the cache is, goes through that change. Similarly, you can also, so key-based event is where you're asking for a specific item. Cache level is whenever the cache, and custom events is the pub sub, where you want to fire, when the application fires a custom event into the cache, and there are other applications that register themselves to be notified. So for example, here in the custom event, this application is registering itself for this custom event. So then when this event is fired, this callback will be called. Anybody. So in this case, it's firing the event itself, but it could be another application. So by having the callback, and again, the callback code is below here. In fact, here's the custom event callback, which just gets the event ID and the data associated with the event. So it's a way to do pub sub. And then eventually there's a continuous query feature, which is a very powerful feature. It's just like a SQL cache dependency, except it's on the cache. So just like SQL cache dependency was a SQL statement that you go to the database, here you're telling the cache, can you please monitor this data set? Again, select customers where customer.city equals San Francisco. Whenever any object with this criteria is added, either added, updated, or removed from the cache, notify me. So, any questions? Again, once you have the cache in, use it for these, because there's a lot of different applications that need these types of capabilities. And by using this, you have suddenly simplified your application greatly. I'll skip the details of why you need the ASP.NET, but you do need, and when you use the ASP.NET, make sure that the cache that you use has replication built in. Let me quickly, I think.
Can you think of like an example application that really took advantage of all these advanced features like event notification and grouping, for example?
The grouping is done all the time, because as soon as you start caching more and more data, you need to be able to access it much more intelligently than just the keys. So the grouping and searching is very common as soon as you do application data caching.
Okay.
The event notification is used a lot of the time when you have multiple applications or multiple instances of the application. They need to coordinate activity with each other. We've seen a lot of financial trading companies, they've got data coming in and they need to do something, and then once they do that, somebody else needs to do something else. So they're feeding on each other. So instead of using the message queues, which, as I said, have their own purpose, we're not, but cache is a much better, much simpler data-oriented events should go to the cache. The cache has the data, So, you could, for example, publish a lot of data to the cache and then fire a custom event that contains all those keys. And then the consumers will consume it, I wanted to quickly go over the edition comparison. I think somebody asked about open source versus NCache. So first of all, NCache has an enterprise edition, which is a fully working copy. You can download it, and it works for 60 days. We can extend it to go beyond easily. There's an open source version of NCache. Open source means Apache 2.0. That means you can use it in any commercial or non-commercial projects without any restrictions. It also does not have any restriction on the number of nodes that you can have in a cluster. We used to have that in our Express edition when we were not open source, but open source has opened it up completely. And if you don't want to download this from our website, because to do so you have to register, you can just go to GitHub. And if I were to go to GitHub, you'll see that NCache is a project here. So let's quickly now see the additions. So of course, the enterprise edition has a lot of features. So if you see that it's almost every, there's a lot that's there. But the open source edition also has, if you come to, I haven't gone through the caching topologies yet. It has 3 topologies, whereas enterprise has more. You can do ASP.NET sessions in this. You can also do the view state in this. You can do memcache, you can do expressions, both types of expressions. You can do item-based events, but not the other ones. You can do basic cache operations like the get, add, insert, remove, and also you can do bulk operations. You can do lock, unlock, which is another API call, which can lock an item until, and nobody can read or write it until you unlock it or the lock expires. Same way you can do searching with SQL in an open source. You can also do link with open source. You can do evictions. You can do perfmon counters, command line tools. There are no GUI tools that come with open source. If you get the professional edition, which is pretty much open source with support, you get all the open source features plus the GUI tools plus support. Then if you were to go beyond indexing, of course, because that's how you search. There's a Windows installer that you can get the open source. So we made open source fairly powerful. Of course, it doesn't have many of the enterprise edition features, but what we've seen is that people who don't have money to spend or their project is not that important, they go with open source. And again, as I said, there are no limitations. And people who projects are more sensitive, they want support, they usually go with enterprise, and that's because the product isn't that expensive. So enough about that. I mentioned this because people asked me. So the view state we've talked about. I'm going to now quickly just go to the NCache architecture, and then we can end. I think we've had a pretty long. So a good distributed cache always builds a cluster, as I said. I will go through NCache architecture. So NCache has a dynamic cache cluster. It's a peer-to-peer architecture, so there's no single point of failure. There's no master slave, no majority rule. Every node is a peer. So that means you can add or remove any servers from the cluster. And the cluster continues to run, and the cache continues to run, the application continues to run. High availability, very, very important. A cache is like your database. You don't want the database to crash in data center, so you don't want the cache to stop or whatever. There's the flexibility in the cluster and the dynamic configuration and the connection failover. The connection failover means if any cache server goes down, all the clients that are connected to it continue to work with other servers.
How many replicas of the data you have on the server?
Okay.
I mean that when you plan the cluster, can you manage the number of replicas?
Okay, let me go through that. So caching topologies essentially are data storage strategies, replication strategies, and connection strategies, all bundled into one. So there are 4 caching topologies. Number 1 is called mirrored cache. It's a 2-node active passive, just like you would have SQL Server active passive, and there's an active database and there's a passive. The same way it works here. all the clients connect to the active node. The entire data is right there. They do all the read-write operations here. Whatever they update here is asynchronously backed up to the passive node. If the active node ever goes down, the passive node becomes active, and all the clients move to this. So the limitation of this is it's only 2 nodes. And this topology is there for those customers who only have one dedicated cache server. Maybe they can use a backup from a web server, or the database is the backup. But other than that, it's pretty fast. I mean, it's a very fast topology. It's just not scalable beyond this. Keep in mind, whenever you program against NCache, your application does not know about topology. So if you change topology, you don't have to change any code. So it's all transparent. Number 2 is replicated cache. This is where every server in the cluster has the entire copy of the cache. And you can have more than 2 servers. Let's say if you have 3 servers, you have 3 copies of the cache. This is, the reads are super fast. The updates have to be done synchronously because all the nodes are active. Active means they have their own clients that could be updating data independently to other servers. So the updates have to be done synchronously. Synchronous means that the entire cluster is updated while the client waits. So the updates are not as fast as other topologies. They're pretty fast, and I'll give you the numbers. In fact, let me quickly give you the numbers before or maybe let me just come back to this. The third topology and the fourth is called partition and partition replica. Partition topology is where the entire cache is broken up into partitions, and the more servers you have, the more partitions you have. And there's a distribution map that gets created at runtime dynamically. A distribution map is like a bucket map. It tells the clients which bucket is in which partition, and what's the hash map value range of each bucket. So that based on that, the client knows where to go to either fetch the data or update the data or add the data. And this with the help of this, the client is able to now connect to all the servers and go directly where the data is. So this makes it extremely fast topology. This is the fastest topology. The only drawback is it has no replication. And the partition replica is a partition with replication. So they both behave the same way, except this has replication. Open source has this topology and partition topology. And it has the local cache, which is the standalone cache. Partition replica is our most popular topology. It gives you the best of both worlds. It scales and also does replication. And as I said, even for application data caching, you want replication because you don't want, even though you can go and get it from the database, it costs you in terms of performance. So you don't want to do that. So most people always have replication.
But in that diagram on the partition replica cache, all the data is still stored in each server, but I imagine that's not generally true. Like I see 1, 2, 3, 4 on both.
Yeah, so let's say partition, I'm sorry. So in a partition replica, the partitions are active, the replicas are passive. That means no client talks to the replica. The partitions talk to the replica, so whatever's in this partition is a copy of it is kept on another server.
Right, so but is it if you have like 3 or more or servers, does each server still have a complete copy of the entire cache or no?
Okay.
Okay.
So let's see this. Let's say that you had a 2 server cluster,
Yeah, that answers that question.
and now you added a third one. So what happens actually, partitions, so what NCache does, it creates 1,000 buckets for each cache, for each cluster. So when you have a 2-node cluster, each partition has 500 buckets, right? When you go to 3, then each will have one third, one third, one third. So that means some of the buckets from partition 1 needs to move here, some of them from partition 2 need to move here. So the partition 3 is sort of buckets extracted from both the existing partitions. But all of that is done at runtime. Dynamically without stopping anything. So notice when you add a third server, a partition 3 is created. It has, again, it takes some of the buckets here, some of the buckets here. And now a replica 2, which used to be here, is created here. And a replica 3 is created where replica 2 used to be. Now, replica 2, this replica 2 is not the same as this replica 2. Why? Because the buckets are not the same. These are 500 buckets each. This is 333, 333, 333 buckets each. And similarly, if you had a 3-node cluster and this one goes down, replica 3 becomes active because partition is gone. But now you have 2 servers and 3 partitions, right? So replica 3 merges itself with partition 1 and 2. And then once it's merged, it's gone. And then a replica 2 is created in its place. Going when a server goes down to go from here to here, again, all dynamic. When you add a server at runtime, all dynamic in case of NCache. So this is stuff that other caches do not always do. And you need manual intervention to stop things and redistribute the buckets yourself. But in case of NCache, it's all done automatically. And a client cache is what I was talking about, which is a local cache on the application server. It could even be in proc. In proc means the entire cache is within your application process. That means all the cached objects are kept in object form, not in a serialized form. That means they're on your heap. So if you fetch them, you're fetching them like your own objects. So super fast. But at the same time, it's not a standalone. It's not a disconnected cache. It is connected to the clustered cache. So whatever is in this cache, if it is updated in the clustered cache, let's say by another client, the clustered cache notifies all the client caches that have that data, so they can update themselves. So it is really fast. It's super fast, local, everything, but at the same time connected. Why do you want to keep it connected? So the data is correct. So if whatever is updated is here because something changed here, is going to propagate all the way up here. And then finally, there's a WAN replication feature. If you have multiple data centers, you want the cache to also replicate the same way that you want the database. So it's an active passive or active active. Active active, there's a conflict resolution that needs to be done, which in case of NCache it does. I'm going to skip all of this. I'm going to skip all of this. Do you want me to go over this a little bit, or do you want me to skip it? Which one? Okay. So as you know, Redis is something that is available on Azure. Microsoft. So Redis Labs is the company that develops Redis. They only provide Linux-based version. If you go to their website, you can't even download a Windows version. Microsoft took their source code and ported it to Windows. We thought, great. They've done a good job. Maybe it's headache for us because Redis is a pretty good product otherwise in terms of the performance and popularity. It turns out that Microsoft is itself not using the Windows version in Azure. So they're using the Linux version on Azure. So they've kept the Windows version open source for people to use. And we've heard a lot of complaints that it's very unstable. We've done our own testing, and it's also very unstable. So if you choose to use Redis as the on-prem cache, you're going to have problems. If you use it on Azure, it's a stable, good cache. The only limitation is that there are a lot of features that NCache has that Redis doesn't. So if those features are something that are important to you, then go with NCache. Even the open source version of NCache has more features than Redis. So again, NCache is purely .NET. Redis is not. It's Linux and C++ based. NCache is also open source. So if the only attraction you have to go with Redis is that it's open source, no need, go with NCache. Of course, I would want you to go with NCache, but in terms of the features, there are a lot of features that NCache has that Redis doesn't, and I've gone through a lot of those features today, like SQL searching, data grouping and tags, read through, write through. Cache loader is a feature that I did not touch, but I think somebody asked me a question, I think you did, about how to pre-populate the cache. So I said NCache has this feature called cache loader, which is just like a read-through handler. It's just your code that NCache calls upon startup, and then you can pre-populate the cache. Database synchronization, relational data, ASP.NET View State, support for Java and others. Let me quickly take you to our website. If you want a more detailed comparison with Redis, just go to our resources comparison page. Go to the Redis versus NCache. I'll quickly.
Just for clarification, the statement about stability of Redis was for the Windows version.
Exactly. No, definitely. Linux is very stable. No problems with that. Linux version is totally okay. I was only talking about the Microsoft port. Here's a comparison. You can download the PDF also. All the features that we went through are mentioned here. Um, so again, we are not. So for example, on performance, we don't comment on the performance. I know personally that their performance is pretty good. So I'm not going to say anything about it. But as a policy, we don't say anything about any other product's performance. We only mention stuff that is documented. So anything that you could see in a very, very unambiguous fashion and say, okay, this is what NCache has, this is what they have. Um, so
And that's the enterprise, the full-blown
exactly,
enterprise version.
exactly. And then you can do the edition comparison and see what the open source has, and you'll see all that too. I think that's the end of my talk. Any questions?